Okay, Stats Kids, my recording stopped partway through the video, so I'm just going to do a short little video of the last couple examples. So we just got done talking about this your empirical rule and doing this example over here where our average was 85 and standard deviation was 5. This next example, they're going to have us do kind of the same thing, but they say that our mean is 10, so x bar this time, or not 10, 100, our mean is 100, and our standard deviation is 15 in this case, right here. So if we map him out on a bell curve, the middle guy is 100, and then we would have to add 15, subtract 15, so that would be like 115 and 85, okay? And then if we do it again, add 15, subtract 15, we were at 130, and we're at 70, and then we could do it one more time if we want. Add 15, subtract 15, that's 145 and 55 is what he will look like. And so what they're, let's do this. I like to look at this middle guy as kind of being like 0, and then the 115 would be like +1, +2, +3. This would be -1, -2, -3. And I kind of label them like that just as being like this is adding 1 standard deviation, adding 2 standard deviations, adding 3 standard deviations, subtracting 1, subtracting 2, subtracting 3. And I kind of label them like that. And that's kind of what this table says up here. So X bar is kind of like your middle, like your 0 on a number line. Then you're adding 1 standard deviation, so that would be like +1. You're adding 2 standard deviations, that's +2. Adding 3 is +3, and then the same on the other side, -1, -2, -3, okay? So here they're asking for what percentage of IQ scores are between 70 and 130, okay? So 70 is right here, and 130 is right here, and that's between like -2 and +2. So between -2 and +2, -2 is this guy, +2 is this guy. And so we have like this rainbow of values right here that's between -2 and +2, and I just wrote over top of it. It is 95%, okay? So that kind of tells us if this data is normally distributed, about 95% of the kids would have scored between a 70 and a 130 for their IQ, okay? So that's kind of how this table is operates a little bit. On the next page, Chebyshev's theorem, we skip over top of that, but we're going to go down to something called a coefficient of variation, or they call it a CV. And basically this allows me to compare and see which thing varies more. So yesterday we talked about how boys and girls, we talked about the heights of boys and girls, and I kind of looked up like the average height for a boy is 70 inches, the average height for a girl is 65 inches, okay? Standard deviation for a boy is 4, standard deviation for a girl is 3.5. And what we're trying to find is which one has more variation, okay? All right, which one has more variation, all right? And so when we do that, we can look at these two values and say like, okay, standard deviation is what tells me the variation, right? And so the boys had a standard deviation of 4 and the girls had a standard deviation of 3. So I'm tempted to say that the boys' values vary more, right? Because their standard deviation is higher. But that's not always the case because boys and girls have a different average, right? So taking that into consideration, the boys might not have more variation. You know, it just kind of depends. So what we do is when they start on different scales, when boys and girls are on different scales and things like that, we do what's called a coefficient of variation. And all we do is, this is what we have here, it's S divided by X bar, which is the standard deviation divided by the average. And then they say take it times 100, and all that's doing is just turning it into a percentage. So you don't really have to worry about the take it times 100 thing. You can kind of do that probably in your head. So what we're doing is to figure out which one varies more. We take S divided by X bar. So this would be 4 divided by 70, and this one would be 30 or 3.5 divided by 65. And we figure those out as a decimal, and then we can convert them to percentages. Again, you don't have to multiply by 100 because you can do that kind of in your head. So 4 divided by 70 is 0.057, okay, which would turn out to be, if you move the decimal, 5.7%, okay? So it has 5.7% variation among the boys' heights, okay? If we take 3.5 and divide by 65, okay, it is 0.054. So this one has a variation of 5.4%. Okay, so, you know, kind of the way that we thought, the boys, the standard deviation was higher, and they do in fact have a higher variation, okay? But it won't always be that way. It won't always be the fact that the higher standard deviation will have the higher variance or the higher you know, coefficient of variation. So the coefficient of variation for each one of these is 5.7 and 5.4, and then we just compare them. So we would say, with this data, the boys do have more variation in their heights. Okay, the girls' heights are more consistently around the same number than the boys are. Okay, all right. Now we're going to do another example of that, and I'm getting rid of this example. I don't want to do Verizon data speeds and earthquakes, so I made up my own example. And we did look these up in class. We said ACT scores go from 0 to 36. And we found the average, and I think this might be across the United States, I'm not really sure, but the average is 20.8, and the standard deviation is 5.8. SAT scores, they said, would go from 0 to 1600. The average is 1060, and the standard deviation is 195. Okay, so when we look at those two, we say, okay, well, this one's got to have more variation because the standard deviation is higher, and that tells me how much it varies. But SAT and ACT are on different scales. So, like the ACT has a smaller scale, so which one actually varies more relative to their scale? Since ACT is on a smaller scale, is 5.8 a bigger number respectively than 195 is to the SATs? We don't know for sure. So what we do is we calculate the coefficient of variation, and it allows me to compare those two things when they are on different scales. Okay, so still just take the standard deviation, 5.8 divided by 20.8 over here, and then this one we're going to take 185 and divide it by 1060. Okay, and we're going to see which one has more variation. So 5.8 divided by 20.8 is 0.27, we'll say 9, which is 27.9%. Again, in the formula, that's the take it times 100 part, which you could probably do in your head, like we just did. Okay, the second one, 195 divided by 1060, is 0.184. So this is 18.4%. So the SAT scores only vary by 18.4% versus the ACT scores vary by 28%, something like that, right? So in this case, even though the SATs have the higher standard deviation, they actually have less variation respectively to their scale, if that makes any sense at all. So ACT would actually vary more. So the ACT is like kind of a wider range of scores versus the SAT people are more consistently scoring around that average range, okay? I hope that made sense a little bit to you, but coefficient of variation is how you can compare those two things when they're on different scales. The homework is posted online, so there's that. That's all I have for you.